Quadratic equations, as you know, are the most important type of algebraic equations. So in this video of Glad to Teach, we are going to have a quick introduction to quadratic equations. That is, in the next 10 minutes, I will try to cover all the important points that you must know about quadratic equations. So here we go. So my first question to you is, what is a quadratic equation? It is the equation of this type: ax square plus bx plus c equal to 0, where a, b and c can be any number, but a should not be equal to 0. Why? Because if a is 0, then this entire term will become 0 and this equation will be reduced to a linear equation. See, here is the example of a quadratic equation: 2x square plus 5x plus 3 equal to 0. See, a, b, c have been replaced by these numbers. So, in proper mathematical language, the quadratic equation would be defined as: it is an equation made from a second degree polynomial in its simplified form. That is, for any equation to be called a quadratic equation, it must fulfill two conditions. First is that it should be of second degree. That means that the highest power of x should be 2. And the second condition is that it must be a polynomial. Now, do you know what polynomial is? Polynomial is any algebraic expression where the power of the variable x is a non-negative integer. Like 2, it is a non-negative integer. Similarly, the power of this variable x is 1, which is also a non-negative integer. But if there is any variable in this entire expression which has a negative power, like let's say x raised to power minus 1 or minus 2, whatever, any negative power, or it has a fractional power like x raised to power 1 by 2, this is another way of writing root x, then it will not be a polynomial, and as a result it will not be a quadratic equation. I hope it is very clear. Okay, so now let me check how much information you have absorbed. What I'll do, I'll give you some equations and you have to tell me if those equations are quadratic equations or not. So let's see how many you're able to get right. So is this a quadratic equation? Say yes or no. Yes, it is a quadratic equation, as it fulfills the two conditions. It is of second degree and it is made up of a polynomial. See, no power of the variable x is either negative or fractional or is under root. What about this equation? Is it a quadratic equation? Yes, this is also a quadratic equation. Once again, it is of second degree and it is made up of a polynomial. Only thing is that this term, the middle term, is missing. That is, b must have been equal to 0. But it is still very much a quadratic equation as it fulfills these two vital conditions. So what about this equation? This one is not a quadratic equation, though it deceptively looks as if it is a quadratic equation because of the second degree. But then if you'll read the fine print in its simplified form, let's simplify this equation further by getting rid of this denominator x, and you know how it's done. Multiply both sides of this equation by x. X multiplied with this x will make it x square, and if we'll multiply this x here, it will cancel this denominator. X times x square is x cube plus x square plus 3 equal to 0. Now it shows its true color. Yes, this one is a cubic equation of third degree. Thus, it is not a quadratic equation. So now tell me, how about this one? You have to get this one right. Is it a quadratic equation or not? This one is a quadratic equation. Surprised? At a first glance, it looks as if it's not even a second degree equation. But then, in its simplified form, once again, get rid of this x in the denominator. So, x times x is x square and plus x and plus this x and this x cancels out, equal to 0. Now, this is surely a quadratic equation. So, quickly tell me, is this a quadratic equation? It is not. Though it is of second degree, but it is not a polynomial, as one of the variables has a root power. So how about this equation? Think twice before answering this one. This is the last example. Yes, this one is a quadratic equation. I hope you are not confused by the presence of this root 2. It was a trap for you. See, the power of the variable x cannot be under root, as then this algebraic expression would not be a polynomial anymore. But a coefficient can have any power. It makes no difference. Therefore, this equation is surely a quadratic equation. See, these are the fundamentals. Very important. With this video, your fundamentals are becoming rock solid. Now we can easily build a skyscraper of knowledge on your strong fundamentals, and it will last forever. So if you want, you can pause me here and take a 5-minute rest. Even I would go and have some coffee. Otherwise, please answer my next question. So do you know how to predict the nature of the roots of a quadratic equation without solving it? The challenge is without solving it. It is like making cheese omelette without breaking the eggs. Sounds tough? Not at all. We can easily do that using a powerful tool called discriminant. And discriminant is equal to b square minus 4ac. And you already know what b, a and c are. They are the coefficients and the constant. So for any quadratic equation, if the value of d comes out to be greater than 0, then the roots of that equation would surely be real and different. Okay, I'll put down these conditions for you, don't worry. If the value of d for some equation is greater than 0, that is some positive number, then the roots of that equation would be real numbers and they would be different from one another. When d is equal to 0, then the roots would be real but they would be equal. And when d is less than 0, that is a negative number, then that equation will have no real roots. In other words, you can say that it will have imaginary numbers as its roots. See, isn't that great that we can have so much information about the equation without even solving it by using this simple formula? But that is not all. We can even predict the shape of the graph of that equation without solving it. Since the roots would be different, thus its graph would cut the x-axis at two different places. See, the graph of a quadratic equation is always parabolic, that is U-shaped, and since the values of the roots are different, therefore it is cutting the x-axis at two different points. So now I'm sure you must have visualized what the graph of this equation would look like. Since the roots are equal, so the graph will just touch the axis at one point. See, both the roots will have the equal or same value. So now tell me, what would be the shape of graph of this equation with no real roots? The graph will not even touch this x-axis. It will be flying above it like a kite. See, no point of contact means no real roots. Okay, so now let me check that how much of this information your mind has been able to absorb. So what I'll do, I'll give you some quadratic equations and you have to predict the nature of the roots. Okay, so quickly tell me the nature of roots of this quadratic equation. So d equal to b square minus 4ac. B square is minus 6 square, which is 36, minus 4ac. 4 times 3 is 12 and 12 times 3 is 36. So 36 minus 36 is 0. D is equal to 0. That means the roots of this quadratic equation would be real and equal. Well, if you were to actually solve this equation, then you could have even confirmed your prediction. The roots of this equation are x equal to 1 and x equal to 1. That is equal. That means this point is 1. So how about this equation? Let's see if you can predict the nature of its roots. So once again, d equal to b square minus 4ac. B here is 2, so 2 square is 4 minus 4ac. 4 times 3 is 12 and 12 times 1 is again 12. 4 minus 12 is minus 8. That means d is less than 0, a negative number. So that means that this quadratic equation has no real roots at all. Just imagine, had this useful formula not been there, then we would have wasted so much of our precious time in exam trying to find the roots of this equation, which has no roots. So this is the last question, but a very important one. So do you know what are the different ways to solve a quadratic equation? See, there can be many ways to solve a quadratic equation, but these are the most popular ones. First way is by factorization. That is, we try to break the quadratic equation as the product of its two factors. See, these are the two factors of a quadratic equation, and once we have the factors, we can easily find the roots as well. The second way is by quadratic formula, which is x equal to minus b plus minus under root b square minus 4ac divided by 2a. And the third way, of course, is by completing the square on one side of the equation so that we can easily take the under root on the other side and solve the equation. See, we try to get a square on one side of the equation like that. So when we take this square to the other side of the equation, it will become plus minus under root, isn't it? As whenever something goes from one side to another, it becomes opposite of what it was, and square root are opposite of each other. So therefore when this square goes to the other side, it will become under root. So now what we have is a linear equation which we can easily solve and get to the answer. Since we have plus minus here, therefore we are going to get two values, that is two roots of the quadratic equation. Now the problem is that every method has its advantages and disadvantages. Like for example, factorization method is supposed to be the fastest method of solving a quadratic equation, but it is not able to solve all kinds of quadratic equation. This method will not work at all if the quadratic equation has conjugate pair irrational roots. Let's say the roots of the quadratic equation are like that: x equal to 2 plus minus 2 root 3. Then you can never solve that equation using this method, and you'll end up wasting a lot of time trying to solve that equation with this method. Now, the advantage of the second method is that it can solve almost all the types of quadratic equations. But the disadvantage is that it is a slower method. That is, it has number of steps. And moreover, you have to always remember this formula. Now, the third method, that is by completing the squares. It also works for all kinds of quadratic equations, and it works exceptionally well for these type of quadratic equations which have irrational roots. But again, it takes longer time, therefore should never be used to solve simple quadratic equations. Otherwise, we'll end up wasting lot of precious time. So it sounds a bit complicated, doesn't it? Just relax. You don't have to worry about anything. For in the coming videos, I have made each of these methods really simple for you using the powerful EasyCal tricks. For example, in the next video, you would see that how by using the simple EasyCal trick, you can do the factorization mentally, and that too in just few seconds. And by using the EasyCal version of this method, you can easily solve any quadratic equation in just few seconds. It really doesn't matter if the roots of the quadratic equation are rational, irrational, whether they are fractions or integers. And you know the best part? The best part is that you don't have to remember this formula. Now tell me, how good is that? Also, in the coming videos, I would be teaching you how to complete the square of any quadratic equation directly. So in short, after watching the coming videos, you would become truly an expert of solving quadratic equations.